Everyone, in this video, let us discuss this problem house robber. The problem description is you are a professional robber planning to rob houses along a street. Each house has a certain amount of money staged. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into on the same night. So this was the point. There is a series of houses are there, so the only thing stopping you is you can't do robbery on any two adjacent houses. That's it. Given an integer array nums representing the amount of money each house, return the maximum amount of money you can rob tonight without alerting the police. So given, let's discuss this problem. So given, the given some houses. Suppose see, in the by array one, the house first house have some price one, second house two money, third house three, fourth house one. The only thing, what is a constraint? You can't take two adjacent houses. Now suppose I start with one. Okay, suppose here let's take this example 1 2 3 1. When I take this example 1 2 3 1, you can start with the first house, so that is okay. So the you can take the first house, you can robbery, and obviously you can't rob the second. Again, you can take the third house. The thing is, here you need to check. Suppose if you want to take the third house, that means at this point, so it's like, the approach is like, if you want, it just like you need to skip every time. Suppose if you want to take third house, that means you have taken 1 and 3, that is 4 you can take. Again, if you when you go to the fourth house, so when you want to take the fourth house, so what are the series you have taken previously? So you can't take 3, right? That means it is like you must have taken 2, and after you should have skipped 3 and you should have taken 1, that means 3 answer. So one way, if you taken 1 3, that is 4, or 2 1, that is 3, so you can take the maximum of it. The same way, like that it has taken. So you are taken in two ways. Now sometimes you can skip more also. Suppose you have 1 0 0 1 2 2 1 0 0 5. In this case, what happens, you can take this one and you can skip, and again you can skip, right? And you can take this one or this one. Which is better? Taking this one is better. So what happens, right? Every time, at every stage, the approach is, let's take the what is the maximum we can take at that situation. I will explain this. So the explanation here is, so let's understand. So here we use here approach is called DP approach. The DP approach looks like this. The DP approach here nothing but you first, suppose you have houses. Let's take here example 27931. Let's take this example 27931. First, let's find what is the maximum value you can take at this point. Suppose you don't have nothing, only you have only one house is there, so you can only robbery one house. Then at this point, the 2 is the maximum value, right? At this house, suppose you have another house, so you have a choice, you can take 2 or 7. So what happens at this point 7, you can take either 7 or 2, right? So suppose you have skipped this 2, let's assume. So 7 is the 7 is the you can take. So what I will take, just take TP of 0 as 2 and DP of 1 as 7. So these are my base values, I can't change either 0, either this one or this one. I need to, however I need to skip definitely. So the maximum up to this point is 7 only. But when you come to here, dp of 2, how you judge dp of 2? So the dp of 2 should be definitely you need to check, either you need to skip this 9, go with 3, or involve 9. If you want to involve 9, that means you need to take that a of 2, that value, and you need to take that dp of I minus 2. Why I said dp of I minus 2? This is the a value, a complete what is the profit at that time. Why? Suppose we go on a series here. So this is called a bottom up approach. So I'll explain. Now if you go for the 3, what you will do, that dp of this number, what you will do, so 0 1 2 3. If you take dp of 3, you will take first a value at that point, and you will definitely, you can't take this value, right? You need to take the next before value. So how will you take the dp of I minus 2? So either you can follow this. So every time you're getting the value, right, what we are doing is, every time you're getting a value, so I'll show you. We are taking first dp array, and dp of 0 you're taking, and dp of 1. So I'm taking the math dot max of nums of 0, nums of 1, which is the highest at that point. Every moment, every time, at that given time, I will only take the maximum value. So if you take dp of 2, what you are doing, the rob current, that is nums of I plus dp of I minus 2, the 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 not previous one, but the next to previous one. And if you look into skip is nothing but dp of I minus 1. So you are skipping the previous one, right? So you need to check, if you skip, so you're checking robo current or skip current, which is the max value. That's it. I'll show you it again. 27931. So here, let's take values. 27931. Now I will take here dp of the first value is here, it is 2 only. Here the maximum is 7. Now coming to 9, definitely here the highest I need to check. Either I can skip. If if I skip, it should be either I need to take the 7 or I need to take the 9 plus 2. So I'll take where the 9 plus 2, that is 11. Now when I go to 3, again I can take the 3 plus the previous highest value, that is 11. Either I need to take this value, or and don't worry, okay, now if you have a question, oh, is this having highest value? No, not like that. Every time it is like, at every stage, if you look, we are just trying to hold the maximum value in it, right? How we are doing, so it's keep, we are updating that, keep on. So 3 plus here, at this moment, what is I'm not taking 7, I'm taking that 11, right? So 3 plus 11, 14. Or you need to take what is the highest value that is available at the 9. So at the 9, it is same, either if you take 2 plus 9, that is 11, right? So instead of this, at this point, the maximum is this one at this. So instead of this, I'm trying to take 7, because if I take this combination, it is like 7 plus 3, that is 10. If I take 2 plus 9, that is 11. So what happens, either you have 27931, either you can take the 2, okay, and then after you can take the 9. So at this point, what, it is the 11 value. But if you're not taking the 2, if you're taking the 7, so you can't take the 9, you need to take 3. So 7 plus 3 is 10. Again you comes here, you need to skip. So you can take 2 9 1, nothing but 9 plus 1 10, 12. Or you need to take 7 plus 3, 10. So the combination is 2 9 1. Definitely you will take this combination. So for that, what I am doing here, the same approach at every stage. So I'll just explain you it again here. At every stage, like uh I'll just explain you this again. So take 2 7 9 3 1. Now if you, so first this is dp of 0, dp of 1, you will take the maximum value. So definitely here 2 is you will take, but here in the 7 you will take 2 or 7, which is greater, 7 you will take. So that means you already decided at this point what is the maximum. Suppose if you take different combination, that is different. Now take 9. At the 9 you can't take 7 obviously, right? So you need to take what is the maximum at this position. That is, either you need to take 9 plus 2 or you need to take 7, so you will take the 11. So if you go to 3, you can't take a 9, so you can't take to 9, but you can take the value 7. And again at the 7, it is not like we are taking 2 7. Suppose imagine we have a 7 comma 2, we already updated, right? So if it is suppose 7 comma 2, at this position we'll already updated with the 7, right? Because we keep on updating. So yeah, that is the point. So 3 we can take either what is the maximum value at the 9 at this position is 11, right? So 11 comma at the point 7, what is the maximum value? 7. So 7 plus 3, that is 10 comma 11. So you will definitely take 11 only. So you need to take the maximum value at the 9. So this one you will take it. Again you go here and try to check it again, what you will take here. So at the 3, so the maximum value we found already is 11, right? Yeah, and at 9 also it is 11. So you take anyone, it doesn't matter. So yeah, it's like that. So here the dp of 0 1, the 2, nothing but we are storing what is the maximum value of profit we can get at the moment. So that is the idea, that was the plan here. So this is completely a, this is completely a top down bottom up approach, because we are going from lowest value, we are going for lowest value to highest value, right? So that is why we can also, so let's run this code. We'll try to run this code here. So this was the code which we just discussed. So here I'll explain this code. So first, I'll taking the DP array and I'm taking 0 as a 0, but the one is the maximum of the first and second one. And coming to the third is, either you can take the third element by skipping the previous element. What is the previous? What is the maximum? DP of I minus 1, 2. Or you can take skip the current one, you can take DP of I minus 1. So in this 2, you will take the maximum value, and that's it. You will keep on checking this, because you have write the I equals to 2, so you will check the 2 3 4, you will keep on updating. At initial you can update it, like it is like a just initialize 0, that is fine. So you can submit, it will run now. So this is bottom approach. I'll explain you now top down approach. So that top down approach is like, first we'll talk in terms of first recursion way. So how this recursion ways looks like, let's discuss. So here first, what is the discussion here happening? uh so we discussed the bottom up approach, right? Let's discuss the top down approach. What we'll do is, the given value is, what is the given value? 27931. So if you take 27931, so nothing but first I'll take, uh so first I'll take the uh I'll just start with a recursion kind of way. That means I'll first choose. So I so here we are nothing but we'll just do the backtracking. Like uh so first I'll call a method here, like whatever we call I'll call a solve method. I'll start from the last element, that is nums dot one is that nums dot length minus 1. So that means suppose 0 1 2 3 4, the length is 5, right? So I'll start with index 4. So what happens, right? First, the current element. So I'll take the current element, the nums of I, plus again I will call recursively the solve of the nums of I minus 2. And I'll skip the element. So solve of is the same kind of approach, the nums of I minus 1. So I'll start with 1. Okay, I'll start with 1. So I'll take the 1 and I'll go for the solve of this one. So because this is a top down approach. And again I'll solve with similarly if at the position 9, again I'll solve with, I'll check with instead of either I can check the value of 7 or check with the value of 2. So for this problem the bottom up approach is more intuitive, but top down also I'm discussing. And the base conditions are nothing but here, as you see. So whenever our I is less than 0, we'll just return that 0. That's it. uh what do you mean? We are calling, right, the solve of nums of. So whenever the index become like the I become uh like whenever the I, we are sending this I, so I will be like 5 4, whenever it is become 1 or 0, right? So in 0 nothing you need to do, it will just return the 0 only. Suppose at the here 7, so you will take the 7 value and you can take the value which is the maximum of these two. So it's like top down approach. So it is like a tree, right? So first like 1, you're either checking, taking the 1, like skipping. It's like I'll take a 1 comma 9 combination, or I'll go to the 3 combination, and again 3. I'll check with the 9, or I'll check with this 3 comma 7 combination, same way. So whenever there's a top down backtracking, so if I just run this code, I'll try to run here. So what is the problem will happen? So there will lot of recursion calls will be there, right? So we'll get a time complexity because this is a 2 power n. So time limit will existed. We can run, but we can't submit because for the larger test case, that is nothing but the TC and yeah. For that, we'll do the memoization. What we are doing memoization. If you look into this, what I'm doing, I'm just using the recursive path. I'm using a memoization. That is nothing but if you look this, I'm taking a memo. I'm filling with -1 every time. Whenever I get maximum value, I'll just store into memo of I. I'll just return that. So what happens if you already found this at that point, if you already found the that maximum value, you don't need to find it again. You need just use it. Yeah, you can go through this codes again. If I submit, it will work. Yeah. So this is how we just discussed house robber problem based on dynamic programming. First using the bottom up approach, then top down approach with backtracking approach and memoization to solve it.